So hello guys, in this video we'll see a Codeforces problem called sum of odd integers. So let me explain the question first. So we'll be given with two integers n and k. So our task is to find if n can be represented as a sum of k distinct positive odd integers or not. So we should use only positive integers. The two should use only distinct positive integers, and we should see whether whether those distinct positive integers add up to a particular sum. So let's look at the sample test case. So first line represents the number of test cases, and the next t lines follows the inputs, say n and k. Okay, so n is 3 and k is 1. So I can take a so I can so here the k is only 1, so I can take only one positive integer, and that is 3, and I can make it to that sum. Okay, yes, and 2 4 1 plus 3 is 4. Okay, I can take that. So 10 3. How is it possible? So it's not possible. Somehow we can't represent 10 as the sum of three distinct positive integers. Okay, then 10 and 2, so 3 plus 7, 9 and 1. So there are multiple ways, but you can just output in one of them. So 16 4, 1 plus 3 plus 5 plus 7. It's one of the I think it's the only way to represent 16 as sum of 4 positive integers, and 16 5, it's not possible. So we can't represent 16 as sum of distinct positive integers. So let's discuss our approach in this video. So before going into the solution, just keep in mind that always odd integer plus odd integer will always lead to even, and if n odd integers are added, if this n is even, we will get the even number. If this n is odd, we will get an odd number. For example, 1 plus 3 will always be 4, plus including one another positive integer, one another positive odd integer, we will lead to 9, which is a odd integer, and adding another 7 with this will lead to 16. So if n odd integers are added, we will get an odd number only if the number of odd elements are odd. So you are clear? I think you are clear in this case. Okay, let's take some cases. Okay, 4 and 2. 4 and 2. So before going into this, we will be using a simple max formula, that is sum of n positive integers will always be n square. So sum of first 3 positive integers will be 9. So 3 square will also be 9. So keeping this in mind, we will go into the solution. So if 4 comma 2, this is n and this is k. So k, what's 1 plus 3? What's the maximum amount of maximum? Not maximum. K equal to 2, n equal to 4. So we should find the square root of n first. What's the square root of n? It's 2. So at max there can be only 2 odd integers which sum up to this value. So sum of n odd integers, consecutive positive odd integers, will be equal to n square. So this value is 4, this is n, so taking square root of n equal to 4, n equal to 2, sorry, n square equal to 4, so n will be equal to 2. So at max k will be you should have at max the k will be equal, at max the k should be equal to 2, only then it is possible, beyond that it is not possible. So in a question, if n equal to some value, so say x, k equal to some value, say y, if root of x is greater than y, then the answer will be -1, indicating that its answer will be no, just depending on the question, indicating that no sum of positive consecutive integers, k positive integers will not sum up to that particular sum. Yeah. So keeping this in mind, let's proceed. Okay. So as I earlier said, sum equal to odd plus odd plus odd plus n times n should be odd to get a odd number. So to get the sum as odd, we should have odd number of positive odd integers, and to get the sum even, we should have even number of positive integers. So we will do one thing, we will have filtered the answer by the above step, by taking the square root, and after that, so can represent a sum which is odd by only taking odd number of odd positive integers. And the same case, if you want to represent a value which is an even, we should take even number of odd integers. Then if n equal to even, then k should be also even. Okay, I'm getting it right. If n is even, k should be also even. If n is odd, k should be also odd. Okay, do you get this? And before checking this, we should check whether square root of n is less than or equal to k. Only after checking this, we should come for this condition. So if n equal to even, k should be also even, and n is odd, k should be also odd. So after final conclusion, first, if square root of n is greater than k, right? Else if n mod 2 equal to 0, if k mod 2 equal to 0, print else no, and else if n mod 2 is not equal to 0. Certainly this would be the case, so there is no use in writing this. But if k mod 2 is also not equal to 0, print else print no. So there is only one simple rule, that if a particular number is odd, we should add odd integers odd number of times. If a particular integer is an even, we should add odd integers even number of times. This condition is the base for this question, and using this we can solve this. So that's it for now. Meet you in the next video.